Analysis of AC through RL series circuit. So what is RL series circuit? RL series circuit means there are two components. One is resistor, one is inductor. So what it will do means it will show the combined effect of resistor and inductor. It will show the combined effect of resistor and inductor. So what about resistor? So in the case of resistor, it is in same phase with current is in same phase with voltage, and in the case of inductor, it is voltage is actually leading by 90 degree. Okay, till now, what was our approach for this analysis? Our approach was first we were writing one formula of current, and then we were doing some derivation, and finally we got one equation saying that current is leading or lagging or it is in phase. But in this case, what we are doing is, with the knowledge what we have learned by studying the previous topic, we are going to apply those knowledge to analyze to do the analysis. Okay, so first I am writing V is the voltage, applied voltage, that is V is equal to RMS value of applied voltage. Uh, then this small letter V is the instantaneous value. So V is equal to Vm sin omega t. And I is the current through the circuit. And VR is the voltage across resistor. So there is a resistor, you can see that I think. So there is a voltage across this resistor is VR, and voltage across inductor is VL. Okay, we understood till that. Okay, and now what we are going to do is we are going to draw the phasor diagram, because here we don't have any formula or something. We are directly do the analysis based on the phasor diagram. Okay, so first what I am going to do is first I am going to draw the current phasor. So why I am drawing the current phasor? That is important because it is a series circuit. RL series circuit. Okay, the heading is like that, RL series circuit. So it is a series circuit. We know that the current is same for both inductor and resistor. റെസിസ്റ്റർ ആയാലും ഇൻഡക്ടർ ആയാലും സീരീസ് സർക്യൂട്ടിലെ കറണ്ട് സെയിം ആണ്. സോ ഐ ആം ടേക്കിംഗ് കറണ്ട് ആസ് എ റെഫറൻസ്. So current is my reference. Now, considering current as a reference, where I have to draw the voltage phasor of resistor. It is in phase, correct? So I have to draw the voltage phasor on the current phasor. Okay. So that is what we were discussing in yesterday's class, the day before yesterday's class. Okay. There is no phase difference for a pure resistor. So we have to draw voltage current phasor on a voltage phasor. Here also we have done the same thing, but we have made I as a reference. So with respect to I, first I have drawn I phasor, and I know that there is no phase difference between voltage and current. So what I am going to do is I have drawn the voltage phasor of resistor exactly on the current phasor. Now, what about voltage of inductor? Voltage of inductor is like it is leading the current. Okay, so we have already taken current as a reference. Now we should draw voltage in such a way that it is leading the current. So in anti-clockwise you have to draw voltage phasor. So I am drawing the voltage phasor like this. Okay, you can see that it is, if you look at the phasor in the anti-clockwise direction, we can say that VL, that is voltage across inductor, is actually leading the current. We can see that. Okay, so again I will explain you. First we have drawn current phasor. On that current phasor, we have considered pure resistor. So on that current phasor we have drawn voltage of resistance. So it is exactly on the current phasor because there is no phase difference between voltage and current. Then we are drawing the voltage phasor of inductor. Since current is a reference, we should draw in such a way that the voltage phasor is leading the current by 90 degree. So we have drawn that also. Now that is for a pure inductor, okay? Pure inductor. So now we have drawn for pure resistor and pure inductor. When it is combined, when this pure resistor and pure capacitor are combined, the resultant vector will be something like this. It will be exactly in the middle of both voltage phasor and current phasor. So I can draw a line like this. Then you just using a dotted line, you join this one. So this is a phasor diagram. The resultant vector is vector V or phasor V. That is the sum of VR plus VL. Okay, is it clear for you? Is it clear? Okay. Now we are taking this equation, that is the phasor V is equal to phasor VR plus VL. So the voltage across the resistor is nothing but current into resistance. So I am writing IR plus, so this is an inductive component. Okay, so voltage across inductor is actually I into XL, but it is a reactive component, so I am adding JIXL. Okay, so similar to IR means what? Current into resistance. So we have for reactive component we have current into reactance. So since it is inductive, I am writing I into XL, inductive reactance. So since this is reactance, I am writing it as JIXL. Yeah, that is how I got this particular equation. This equation IR plus JIXL. Now what I am going to do is, since I is common, I am taking I outside, and now it become I into R plus JXL. I into R plus JXL. So that is the total voltage. Okay, total voltage of resultant phase. Now finally what I am doing is, I am rewriting R plus JXL equal to Z. Now the equation between it becomes V is equal to I Z, where Z is nothing but R plus JXL. Okay, what is this Z? This Z is called impedance. This Z is called, so you can see here where Z is R plus JXL. Okay, so it is called impedance. So we will see what is impedance. So this is impedance. So whenever there is a circuit, impedance is the effective resistance of electric circuit or component. So it is the effective resistance to an alternating current arising from the combined effect of ohmic resistance and reactance. Sentence is actually a little bit lengthier, but we will see what is impedance. Impedance is the effective resistance. It is nothing but a effective resistance. It is not a resistance, but it is effective resistance. What is this effective resistance? This actually occurring in only in AC. Okay, no, it is not available in DC. It is only in DC. It is arising from the combined effect of ohmic resistance and reactance. So whenever there are reactive components and resistive component in an AC circuit, so it will combine together and it will form impedance. Okay, so resistance also a kind of resistance, reactance also a kind of resistance. When both are combined, we are calling it as impedance. So equation for impedance you can see here: Z is equal to R plus J X. Maybe it is capacitive or maybe it is inductive, depends on that. So this is the formula just before we have derived. So that's about concept of impedance. So we got a formula like this. So how to find out the magnitude of impedance is using this formula. That is, uh, you have to square it. So it becomes Z square plus R square. Okay, like that it will finally you take the square root of that. Okay, J square is actually minus 1. Okay, 1 minute. Um, Okay, it is based on the this one complex formula. The magnitude of impedance is equal to square root of R square plus XL square. Okay, and the voltage here also we have two vectors. V is equal to VR plus VL. So this voltage magnitude is equal to square root of VR square plus VL square. So that is how you have to uh, write the expression. Okay. Now about the three terms set XL and resistance. So you can draw a resistance triangle. XL is actually the resistive component. Then you draw here. So sorry, R is the resistive component. You draw here, and XL is the in the imaginary plane. Okay. Again, I will show you that. Okay. In uh, resistive component is in real plane and imaginary component in uh, XL is in imaginary plane, and the resultant one. Okay, so it is the impedance actually. So then you, if you draw the triangle, resistance triangle, you can say that this end is of resistance, this length is of reactance, and the hypotenuse is of impedance. And okay, again, once again, first what I am doing is resistance I am drawing in real plane because Z is equal to R plus JXL. Okay, R is in real plane, so I am drawing resistance in real plane and impedance, sorry, reactance in imaginary plane, that is XL, and the resultant is the hypotenuse is impedance. Now, if I draw the triangle, power triangle, this length, this length and this length are same. So I can say that this is XL. So I can draw the triangle like this. Okay. So R, XL, Z. Now what I'm doing is I'm writing an angle phi over here, and then I'm saying that the power factor is nothing but cos phi. It is the cos phi. How to take cos phi? It is the adjacent side by hypotenuse. So r by z. So we will see what is power factor now. Power factor is the angle between voltage and current in a given AC circuit. Okay, so it is normally given by cos phi, the formula. So if you have any triangle, resistive triangle, the power factor is given by R by Z. Is given by R by Z. Okay. Now, what about? Can you say how much angle? Okay, it is an inductive circuit. Resistance also there. Can you say which one is leading in this circuit, and by approximately how much angle? I can say that since there is an inductor, I can say that the voltage will be leading in this circuit. Voltage leads the current. And what about the angle? It is not 90-degree because it is not a pure inductive circuit. There is a resistor also. So the angle will be less than 90-degree. So in an RL circuit, the voltage leads current by an angle less than 90-degree. Okay, so in some exam, they may ask like this. Uh, Prove that in an RL circuit, the voltage leads current by an angle less than 90 degrees. Then also you draw the same explanation, uh, same derivation, and say that because of this reason, because of the combined effect of resistance and inductance, for pure inductance it was leading by 90-degree. For pure resistor, it is exactly on the current phasor or voltage phasor, and there is no phase difference between voltage and current. But when combined effect is there, so you can draw this phasor and say that it will be between 0 and 90-degree. Okay, is it clear for you? കുറച്ച് ടഫാണ് മനസ്സിലാക്കാൻ നോക്കുക. ക്ലിയർ അല്ലാത്ത ആരെങ്കിലും ഉണ്ടാവും? Okay, what you have to do is you have to whenever they are asking analysis of AC circuit through RL series circuit, first you have to draw the circuit diagram. Then you say what is voltage, V is the RMS value of applied voltage, I is the RMS value of current, VR is the voltage across R, VL is the voltage across inductor. That much you can write. Then you draw the phasor diagram. How to draw the phasor diagram? Takes for every circuit, wherever you see a series circuit, you take current as a reference. Okay, then you draw, if resistance is there, you can draw voltage phasor exactly on the current phasor. And for inductor, you can say that the voltage is leading current by 90-degree. So you can draw that. So after that, you can write the expression of resultant vector. Then you write the formula of voltage and across resistor and inductor. Then you write the V is equal to IS set formula, and finally resistance triangle. That's it. അത്രയും മതി. അത്രയും ക്ലിയർ അല്ലേ? And also you have to say Z is equal to impedance. ഞാൻ പറഞ്ഞു ഇത് മനസ്സിലാവണമെങ്കിൽ ആ മുമ്പിലത്തെ രണ്ട് ടോപ്പിക്ക് പ്യുവർ റെസിസ്റ്ററും പ്യുവർ കപ്പാസിറ്ററും പ്യുവർ ഇൻഡക്ടറും നല്ല രീതിയിൽ മനസ്സിലാവണം. നല്ല രീതിയിൽ പഠിച്ചു കഴിഞ്ഞാൽ മാത്രമേ ഇത് ക്ലിയർ ആയിട്ട് മനസ്സിലാവും. ഓക്കെ, ഇപ്പൊ അത്യാവശ്യം കത്തിയാവും. Okay, we will discuss the next one. analysis of AC through RC series circuit. So both are same. Okay. First, you have to draw the circuit diagram. What is the difference between previous circuit diagram and this circuit diagram? മുമ്പിലത്തെ തൊട്ട് മുമ്പിലത്തെ സർക്യൂട്ട് ഡയഗ്രം ഈ സർക്യൂട്ട് തമ്മിലുള്ള ഡിഫറൻസ് എന്താ? ആരെങ്കിലും പറയും. What is the difference between the previous circuit diagram and this circuit diagram? Previously, it was RL circuit, RL series circuit. So there we had resistor and inductor. Now it is RC series circuit. We have resistor and capacitor. So that is the difference. Then you write V is equal to RMS value, I is equal to RMS value of current. V is the voltage drop across R. VC is the voltage drop across capacitor. Okay. Then again you write what you have to write. You have to draw the phasor diagram. First you take, since it is a series circuit, first you take current as a reference value. Then we know that, what do we know? We know that voltage and current are in phase. So what you do on the on the current phasor, you draw voltage phasor. Again, you know that in a capacitive circuit, what will happen? Current leads the voltage by 90 degree. So you have to draw voltage phasor of capacitor in such a way that it is lagging the current phasor. So anti-clockwise direction ആരാ മുന്നിലുള്ളത്? കറണ്ടാ മുന്നിലുള്ളത്. So you draw in such a way that this like this. Now what about the resultant vector? Resultant vector you have to draw in between these two vectors. This is the resultant vector. Okay, so since look at the phasor diagram now. So it is in the negative side. Capacitor voltage phasor of the capacitor is in the negative of imaginary axis. Okay, again look at the phasor diagram. This phasor, if you look at the phasor diagram, you can see that the capacitor voltage is in the negative side of imaginary axis. So what will be the voltage value of capacitive phasor, voltage phasor? It is minus JIXC. It is in the imaginary axis, right? So it is my negative imaginary axis, so minus JIXC. In the previous case, in the case of inductor, it was in the positive imaginary axis. So JIXL was sufficient. Now it is in the negative imaginary axis. Then you write minus JIXC. Now what you will get? If you write the expression for resultant vector, it is IR minus, or you can write like this also, IR plus minus JIXC. So that is, what is the result of that? IR minus JIXC. Again, the same step I am following. I am taking common I of R minus JXC and write like this. So finally I am writing V is equal to I set, where Z is R minus JXC. So there will be no numerical. So in the case of RL circuit, the formula for impedance Z is equal to R plus JXL. But in the case of capacitor, you note that it is not plus sign, it is minus sign. So Z is equal to R minus JXC. And also formula for impedance, the magnitude of impedance is same. It is square root of R square plus It is based on the triangle. Okay, what triangle? Resistance triangle, or I can say the phasor based on the phasor. So this is nothing but resistive component. This is reactive component, and hypotenuse is the impedance. Hypotenuse is the impedance. So as per the triangle law, what we can say that the impedance, total impedance is equal to, or hypotenuse square is equal to adjacent side square plus opposite side square. So what is impedance? Z is equal to square root of r square plus xc square. Then everything remaining everything is same because this formula is same for both inductive circuit, RL circuit and RC circuit. Okay, so for an RC circuit, current leads the voltage. So RL circuit voltage was leading, but since this is RC circuit, current leads the voltage, but angle is not exactly 90 degree, angle is something less than 90 degree. ഇവിടെ മനസ്സിലാവുന്നുണ്ടോ ഈ മോഡ്യൂൾ കഴിഞ്ഞു പോയാ അനസ് റോഷൻ
Sir, sir.
അനസ്
Present, sir.
അനുഗ്രഹ്
Present, sir.
അശ്വൻ ധ്യാൻ
Present, sir.
ഫാത്തിമ നദ
Present, sir.
സഫ
Present, sir.
സന
Present, sir.
ജ്യോതിഷ്
Present, sir.
കൈലാസ് കൈലാസ് മുഹമ്മദ് മുവാസ് ഫറൂഖ്
Present, sir.
നീഹ
Present, sir.
നിഖിൽ ദാസ്
Present, sir.
പ്രണവ്
Present.
സായൻ
Present.
എടോ എന്തെങ്കിലും ഡൗട്ട് ക്ലിയർ ആവാണ്ടുണ്ടോ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ നിങ്ങൾ വർത്തമാനം പറയാതിരിക്കുന്നത് ഞാനിപ്പം പേപ്പർ വാല്യുവേഷൻ ചെയ്തുകൊണ്ടിരിക്കുകയാണ് അപ്പം കുറേ നല്ല ആൻസേഴ്സ് ഉണ്ട് നല്ല രീതിയിൽ എഴുതിയ കുറേ പേപ്പറുകളാണ് ഇപ്പം നോക്കിക്കൊണ്ടിരിക്കുന്നത് ഇലക്ട്രിക്കൽ ആയാലും ഇലക്ട്രോണിക്സ് ആയാലും അതിനകത്തുള്ളൊരു ക്വസ്റ്റ്യനാണ് ഇങ്ങനെ ചോദിച്ചിരിക്കുന്നത് അതായത് പ്രൂവ് ദാറ്റ് എന്താ പറയുക ഇൻ എ കപ്പാസിറ്റീവ് സർക്യൂട്ട് ദ കറണ്ട് ലീഡ്സ് ദ വോൾട്ടേജ് by an angle 90 degree. Also prove that the total power is zero in a pure capacitive circuit. There is one question. Okay. So actually we didn't discuss that question in classroom. But if you understand the concept, you can directly write the derivation of pure capacitive circuit and say that it is leading by an angle 90 degree. And then later what about power? I was also explaining the power. You can draw this waveform and you can divide this waveform into four quadrants and say that there are two positive half cycle positive power, two negative power, and then if you add everything, it will become zero. So average power is zero. You can prove like this if you know the concept. അണ്ടർസ്റ്റുഡ് മെനി സ്റ്റുഡൻസ് ഞാൻ പേപ്പർ നോക്കുന്ന ആ കോളേജിലെ കുട്ടികൾക്ക് നല്ല രീതിയിൽ അത് എഴുതിയിട്ടുണ്ട്. Okay, so if you know what is the basic of R, L, and C, it is very difficult for you to learn what is RL, what is RC. Okay, first we have to draw the circuit diagram, then phasor diagram. While drawing the phasor diagram, then you have to write these sentences. Write V is equal to RMS value of ambient voltage, I is equal to RMS value of current, then VR is equal to voltage across resistor and VL is equal to voltage across inductor. Then you have to draw the phasor diagram. How to draw the phasor diagram? For both the case, the steps are same. First, you draw the current phasor as reference phasor. Then you look at each component. First, you take resistor. So, resistor voltage source, voltage phasor. It should be drawn above the current phasor because both are in same phase. You draw that one. Then you take inductor. Inductor means voltage is leading the current. Then you draw such a way that it is leading by an angle 90 degree. Then take the resultant vector and write the formula for resultant vector and do some steps and find out what is impedance. That's it. Then you can draw the resistance triangle or impedance triangle. The same case for applicable for RC series circuit also. Okay, clear ആയോ ഇത്? Okay, and now let me take the power factor session also. Once again, I will explain you power factor session. Okay, for every AC supply, it is preferred that the voltage and current are in same phase. But due to some conditions, like നമ്മളിപ്പം വീടുകളിലാണെങ്കിൽ നമ്മൾ വീടുകളിൽ ഏത് ലോഡാണ് കൂടുതലുള്ളത്? റെസിസ്റ്റീവ് ലോഡാണോ, ഇൻഡക്റ്റീവ് ലോഡാണോ, കപ്പാസിറ്റീവ് ലോഡാണോ? നിങ്ങൾ പറ. വീടായാലും ഇൻഡസ്ട്രിയിലായാലും ഏത് ലോഡായിരിക്കും അവിടെ കൂടുതൽ ഉണ്ടാവുക? It is inductive load. Why? What is the reason? We have fan. In every room we have one fan, and then we have motor, grinder, mixer grinder. Then in the refrigerator we have motor or pump. Then in washing machine we have motor. Then induction cooker there is an also inductive coil. It is actually so everything is inductive load. Industry you will be having n number of a lot of motors. So there are also inductive load. There is no much capacity loads are available. Most of the loads are inductive load. Most of the applications are inductive application. So what will happen means there will be a combination of resistance and inductance, and the current will be always lagging behind the voltage. So I can draw like this. So in an inductive circuit, we know that which one is leading, voltage is leading. So if this is voltage phasor, I can draw the current phasor. Okay, so for every home or every industry, this is the situation. Voltage and current are not in phase. The current will be lagging behind the voltage. So it will cause lot of losses for the power supplying industry and also the industry where we are using this or where we have taken the connection. So it is preferred that the voltage and current should be in phase. And for understanding that one, how much variation is there between voltage and current, we have introduced a term called phi. And the angle, so okay, I can say that the angle between voltage and current is phi. And we have introduced a term called power factor, and that power factor is given by cos of that angle, cos phi. Phi is the angle between voltage and current, and power factor is cos of that angle. That is adjacent side by hypotenuse. So that is the power factor. If you so what they will normally do means, they will add capacitor parallel to this load in industry, or if you can look at the rice mill also, because they are using heavy motors and all. They will be keeping a small capacitor box near to their uh, meter or switchboard, etc. Capacity load or capacity box. So what it will do, it will cancel each other. The inductive and capacitor is just opposite in nature, and it will cancel all the inductive effect. So this is the concept of power factor. The angle, cosine of angle between voltage and current in a given circuit is power factor. ഓക്കെ, നമുക്ക് ബാക്കി അടുത്ത ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്യാം.